Our presenter is Matt Stoltz. He's worked passionately for the past 20 years assisting municipalities across British Columbia implementing solutions for water and wastewater monitoring. With 2 decades centered around metrology and remote monitoring technology, Matt has a wealth of knowledge and experience to help solve the challenges municipalities face with this. Matt began his career in the waterworks industry as a project manager overseeing municipal installation projects across BC, and then worked as a regional manager for a distribution company. Seeing the lack of local expertise, specifically focused on wastewater and stormwater monitoring solutions, Matt decided to take the plunge into business ownership and founded Flow Systems. Flow Systems works with municipalities across the province supplying and installing smart technology products to monitor water, wastewater, stormwater, surface water, and H2S. We'd like to welcome Matt to the stage.
Thank you very much, Anna, and thank you all for sticking it out for this last session of the day. Well, 2020, who's ready for this year to be over? This has really been a year unlike any other, and it's forced us to rethink how we do a lot of things. Some of these changes will, of course, be temporary, while some may very well change how we do things forever. Take today. It's pretty strange to be presenting in this empty room, and yet, through technology, we're all able to be here, albeit in a virtual environment. As Anna mentioned, my talk today is going to focus on some common challenges that operators face in their collection systems, specifically wastewater theme, and how utilizing remote monitoring technology can not only assist your operations, but also help future-proof the system. Now, collection systems may represent the least technologically advanced component of the entire utility. However, they play an obvious crucial role. Typically driven by gravity and completely out of sight, our collection systems really only become noticeable when they back up and produce overflows or emit odors, events that historically were very difficult to both predict and prevent. And in the future, our collection systems will take on an even greater role protecting the sustainability of our water resources and managing extreme weather events. Because of that, it's critical we take a look at our collection systems and see where innovations in technology can assist us to make proactive decisions rather than reactionary ones to better protect the public health and the environment. And as our collection systems continue to age and changes to our climate continue to occur, an even greater need to understand the real-time conditions under which our collection systems operate is emerging. This will assist proactive utilities across the province in 4 key ways. First, being able to maximize the operational availability of our existing constructed infrastructure. Second, being able to adapt to rapidly and dynamically changing water levels in our collection systems, as well as varying levels of total suspended solids. Being able to maximize effectiveness and reduce overall cost of operations. And last, to better protect the environment. Now, my previous slide mentioned being able to maximize operational availability. So what is operational availability? Well, it can be defined as the ability for a system to operate as designed when required. And for a collection system, this means being able to transport wastewater or stormwater, depending on the collection system we're talking about, and be able to do so under a wide spectrum of operating conditions. Those include things like significant and rapid changes in flow conditions due to inflow from storm events, or infiltration due to high groundwater levels or soil saturation. Also external impacts like the buildup of fats, roots, oils, and grease, what we like to call frogs in the system, as well as being able to manage H2S that can generate odor complaints from your constituents and businesses, and which can ultimately lead to the corrosion of concrete pipes. So being able to squeeze every last drop of capacity out of our existing collection system assets it's important that we understand the dynamic conditions under which they operate. Due to the harsh environment of a sewer, real-time data collection, transmission, and monitoring used to be a very challenging thing to do and required a confined space entry to both install and maintain the sensors. However, innovations in robust, non-contact sensors and long-life batteries has really made real-time diagnostics in our collection systems easy to do. Sensors can now be installed without having to ever physically enter a manhole, and with many providing options that give you visibility from the bottom of the invert right to the top of the manhole lid, much like you can see on the screen right now. These simple-to-install sensors, once installed, allow for a very proactive approach that helps improve operational efficiency. Today for this presentation, I'm going to hone in on 3 key areas where remote monitoring technology can assist your operations. The first one being reduction of high-frequency cleaning and prevention of sanitary sewer overflows. The second one is managing H2S gas, or at least the levels of it. And the last one, inflow and infiltration. 3 common problems experienced by many municipalities across the province. So this year, COVID-19 has really shown us we need to be able to expect the unexpected. It's had a real profound impact on public works departments across the province, across the country, and really across the world. And we really should commend our operators and management of every public works department for being able to adapt on the fly to the challenges you faced in keeping that essential water and wastewater system running smoothly this year. Now, on the wastewater side, many departments have had to scale back their sanitary cleaning and flushing programs. For some, this was due to concerns of potential exposure to COVID-19 in wastewater, while for others it was more simple of a reason, where lack of staff due to some staff having to work remotely on revolving schedules. Unfortunately, though, the increased use this year of personal hygiene products, things like wipes and masks and gloves, has led to a lot of these products being improperly disposed of, causing an uptick in blocked sewer pipes across the province. And we've seen blockages like this from numerous municipalities that we partner with, but they do benefit where remote monitoring is in place to give you an advanced warning of potential backups. Now, cleaning is a necessary function to maintain your sanitary system. Typically, though, this is done on a calendar-based approach, whereby the same sewer lines are cleaned in the same frequency in perpetuity. Cleaning programs are not only very labor-intensive, but require expensive machinery to purchase, that driving around town all day contributes to the carbon footprints of our cities, and when cleaning is used excessively, also accelerates wear on pipes. With the advent, though, of smart sensors, there is another way to tackle this maintenance program. So being able to know which pipe segments need cleaning and when they need cleaning can result in substantial savings to your operation. Rather than cleaning Main Street simply because it's September and it's been 3 months since the last time you cleaned this pipe segment, utilities can monitor the levels in their system remotely and locate pipe segments that are beginning to show buildups, or conversely, low flow conditions that might be contributing to the accumulation of solids, allowing for strategic targeting of your cleaning operations. Tackling this maintenance program with real-time data can not only reduce costs, but also keep your crews safer by potentially reducing the amount of high-frequency cleaning needing to be done, and therefore reducing their exposure to the actual wastewater. And utilities who have embraced this type of technology for pipe segments that are subject to high-frequency cleaning intervals have been able to reduce their cleaning frequency by as high as an astounding 95%, while virtually eliminating overflows for all of these monitored pipe segments. Now, while not as widely adopted here in BC yet as in other parts of Canada and indeed for sure across the continent, this is beginning to change, with numerous municipalities starting to take a look and a data-driven approach to their cleaning programs. There's numerous municipalities across BC who are already putting this type of technology to work for them. Now, not only are these remote monitoring sensors able to give utilities a visibility into the water level and send advisories when higher than to be expected water levels in the collection system are detected, some systems have built-in machine learning tools. And what those are doing is looking at the daily diurnal pattern at a location, and when they detect an unusual change in that diurnal pattern, whether due to water levels trending higher or lower, will automatically push out an advisory to the utility. With this, a real hands-off approach to the cleaning maintenance schedule can be taken, whereby letting this system tell you the pipe segments that are of concern. Cleaning can then be done on a planned, as-needed basis rather than a calendar-based approach to areas in your collection system that you're currently cleaning on a high frequency. Now, on the graph here, you'll see a municipality that illustrates this quite well, this machine learning tool. The diurnal levels at this location were quite consistent, so the peaks and valleys were very, very consistent until one day a trend level rise was detected by a sensor and pushed out an advisory to the utility. The operations department of this city, working with that sensor provider, decided they would CCTV a pipe segment downstream of the sensor. And what they found was a sludge buildup beginning to occur. So they decided they would continue to monitor this location for a period of time and watch the levels slowly begin to increase until they got to a point where they felt it was time to clean. Now, of course, you don't need to actually CCTV your pipe segments. You can simply monitor levels remotely and let the system tell you when it's time to clean. Here's a couple examples on the screen. You should be able to see the screen here of this type of technology in action here in BC. On the left, you can see a location from the city of Prince George. This location is subject to a lot of fat, oil, and grease buildup downtown. And what they decided to do was put a remote monitoring sensor upstream of that location. And now what they do is they monitor the fog buildup and watch the levels in this location slowly rise. And when the data tells them it's time to clean, they can go out and clean. Conversely, the graph on the right is from the city of Fort St. John. And this one's showing the opposite thing happening, a trend level fall. This could be caused by a couple of things. So it could be some sort of an upstream restriction, so reducing flow to the monitored segment. So when you have remote monitoring sensors installed, you're getting visibility both downstream and upstream of your monitored locations. Or it could be a more simple reason. It could be because they conducted a cleaning program, increased capacity in that pipe segment, and the levels have dropped down. Utilities, though, have, once you have your remote monitoring in place, do have the data they need to make these types of informed decisions. And all vendors will offer some sort of a cloud-based secure web portal so you can access the data. Some will offer you a mobile app as well so that you have this insight right in the palm of your hand. And most will also offer some sort of an API if you want to be able to push this data into a SCADA system or whatever it is you want to push the data to. This slide's pretty busy. There's a lot of numbers on this screen, so I'll quickly walk you through it. The City of San Antonio Water Service, or SAWS is their acronym, is quite widely regarded as one of North America's leaders when it comes to technology adoption and innovation in their water and wastewater system. Like most cities, they have locations that are subject to a lot of fat, oil, and grease buildup that require regular maintenance, with some pipe segments having to be cleaned every single month. And you may have some sensors, or some pipe segments in your city that you have to clean every month. And what they decided they would do is do a pilot where they put 10 sensors in locations that had to be cleaned monthly and would only clean when the data told them it was time to clean. So quick and easy math, 10 sensors, 12 times a year, that's 120 cleanings they used to do on these 10 pipe segments alone. And what they found quite interestingly after this pilot in 2016 was they only actually had to do 7 individual cleanings, or a 94% reduction in high-frequency cleaning at these pipe segments. Now, a city that size, of course, has much more than 10 pipe segments that are subject to high-frequency cleaning. So they decided in between 2017 and 18 to deploy sensors to basically 200 of their worst sites. And these were sites that were being cleaned monthly, bi-monthly, and a couple of quarterly ones that kept them up at night, and left the sensors in, let them do or tell the city when it was time to clean. And some interesting data that came back. So normally, these 200 pipe segments would require about 1,200 on average every year cleanings. Last year, the first year they actually had all the sensors installed, they only had to do 65 individual cleanings or a 95% reduction in this high-frequency cleaning. So a massive reduction in the cleaning, but also the payback for their cost of these remote monitoring sensors was quite literally months for them. Now, I do have a video where they speak to the successes of this pilot. And if anyone wants to see this video after the presentation, you can just simply reach out to me, and I can send that along to you. Now, cleaning is, of course, primarily done to reduce buildups, which could lead to sanitary sewer overflows. However, there could be other locations in the collection system that really keep you up at night. You know, those areas that are prone to backups, like siphons, things like that, problematic areas, or maybe areas that would be environmentally or financially, or maybe it's even politically, a nightmare should a backup occur. So think of those locations as the low-hanging fruit or the obvious first locations you'd want to consider remote monitoring technology. Because this remote monitoring gives you around-the-clock warning of potential problems to prevent spills. So some common areas to monitor would include sewer pipes that run through easements or other environmentally sensitive areas. Maybe you've got areas in your system where you've got a planned future capital improvement project to reline or replace pipe, but that could be years out in a multi-million-dollar project. In the meantime, a remote monitoring sensor could be a very inexpensive way to babysit these pipes. Another one could be an obvious one. If you've had a past spill, putting a remote sensor in there to avert you and prevent future spills is going to be a fraction of the cost of that spill. Never mind the PR nightmare of dealing with the residents of a second spill in the same location. Okay, and we're going to switch gears now. So that kind of covers off high-frequency cleaning and SSO prevention. The next topic we're going to touch on is H2S. So one of the consequences with new low-flow plumbing devices in our houses for water conservation, which has been widely successful in reducing potable water usage in the house, has been an overall reduction in wastewater hydraulic flows during dry weather periods. In our wastewater system, reducing the amount of water but transporting the same amount of solids leads to, of course, an increase in total suspended solids. This increase in solids also increases the potential for them to decompose down the lines, particularly in flat slope sections, and potential generation of hydrogen sulfide, or H2S gas. And this is the second operational challenge we're going to discuss how remote monitoring can assist. Managing H2S for municipalities out there that are having problems with this is often addressed by a combination of flushing, pH control, and chemical dosing. Previously, H2S levels had to be obtained on-site, so a more reactionary approach to this was taken. However, much like the monitoring of storm and sewer water levels, advances in remote sensors for H2S gas also allow for the remote monitoring of this as well. Some sensor providers can also integrate precipitation data and even information from right in the manhole, giving you temperature information, which can be helpful to see how these are affecting H2S levels. More on temperature and precipitation data is coming up in a couple slides, so I'll skip right over that. Having this information, though, remotely on H2S levels can assist your flushing and chemical dosing programs, make them run more efficiently and economically, and also with the ultimate goal, of course, of reducing customer odor complaints and mitigating corrosion of our concrete sewer pipes. The city of Kelowna, and you'll see a couple of charts on the screen right now, they were an early adopter of remote H2S monitoring here in our province. They're actively and remotely monitoring H2S at numerous locations across the city, assisting them with not only odor complaints, but also their chemical dosing program. These sensors are providing them not only with H2S levels and automatic high-level notifications, but they're also able to remotely control their dosing levels, so their nitrate dosing levels, all without having to roll the truck. So optimizing their crew time and reducing the amount of expensive nitrate salts having to be used. And I have a couple graphs up here from the same location in the city of Kelowna. I'm just going to take a look down at these graphs here. The location on the left, it's downstream of a leachate pond at their solid waste facility. So they, like every other solid waste facility, has a leachate pond where solid waste breaks down with the combination of rainwater, and they treat on site. But when the levels get to a certain point, they have to discharge. They discharge into the sanitary and treat that to mitigate the potential for H2S downstream. The graph on the left was right after this H2S sensor was installed, and you can see very active, constant H2S levels. It almost looks like a yo-yo up and down, but consistent, constant H2S levels here. I just ran a graph over the weekend to throw on this slide deck on the right, and that's the exact same location over the past few months. And you can see that the amount of spikes in H2S that they're getting at this location now are very sporadic, and in fact, over the last couple months, are pretty much non-existent. So that would suggest to me that they're really starting to get a handle on this dosing program, and certainly the assistance of remote data is a component to that. Here's another location, also in the city of Kelowna. This location will get H2S levels in that 5 to 10 parts per million range. And if you're not familiar with what that means, that's that range where your nose can smell that wonderful rotten egg smell of H2S, and where you're going to get odor complaints from your residences, businesses, and what have you. But having a remote window into H2S levels and an automatic notification when user-defined high levels are hit can be a real benefit in addressing this. One of our attendees online today, I believe, is Mike Goslin, who's the manager of wastewater operations for the city of Kelowna. Mike, I'm not sure, I don't believe you're able to audibly talk to me, but if you have anything you want to add, you could certainly throw it into the chat or a question, and I'll get to that at the end, and I will get to that at the very end of the program. And you may have actually seen this summer in the Watermark magazine where Mike shared a piece where he highlights their use of just this, remote monitoring technology to assist them in their H2S levels and their chemical dosing program. And Mike, since you can't talk, you can't say no. If you want some more information, you can certainly reach out to Mike for more info, or if you don't have Mike's contact info, then you could certainly start with me. The last operational challenge we're going to discuss is how remote monitoring technology can assist with I&I detection. So every municipality has some level of inflow and infiltration happening in their collection system. For some municipalities, this added volume of rain can present some major issues. Using remote monitoring technology, coupled with precipitation data, municipalities are able to get a cause and effect on when and where I&I is happening in their system. So how do we capture the rain amounts? There's a couple options out there for obtaining this data for precipitation and temperature information and sending it back via the cloud to the exact same platform where the storm and sewer water levels reside. Some companies will utilize traditional tipping buckets that work on kind of a fill and spill concept, while others will utilize highly accurate virtual rain locations. And what they use is very accurate radar-based data to send the precipitation data back. And one nice advantage to these virtual options over typical tipping buckets is no maintenance. They're not a physical site, they're a virtual site, so you can install them, if you will, with simple GPS coordinates and move them around as frequently as you like with the same thing, with simple GPS coordinates. So having that real-time information on our water levels and our precipitation are the first key pieces in identifying locations with high I&I issues. So that's great. We've got now all this data. We've got it all in one spot. But no one wants to have to crunch those numbers and look at, Tuesdays at 3 o'clock. This is our normal levels to be expected in October. Compare that to another Tuesday at 3 o'clock when a rain event happened, and what did that do to levels, and how much rain is that? So in the past, most would outsource that, get a study done, and get it sent back to them. Advances, though, in machine learning and reporting tools with some vendors now enable this to automatically be done, comparing dry weather periods to wet weather periods, and telling you exactly which locations are showing the highest I&I impact. So essentially what this artificial intelligence tool is doing is looking at the normal levels to be expected on certain days and certain times in dry weather periods, and comparing that to the same days and times during rain events and looking at the difference with that difference being our INI impact percentage. On the screen, you should see an example of an INI report just like that from the city of Fort St. John. The northeast of the province, and it's certainly not just Fort St. John, it's an interesting area because the summers can be very dry, but they can get some rain events that come through infrequently, but when they do, are extremely heavy and can wreak havoc on their sanitary and stormwater systems. So what they're using this for is to get a handle on which locations in the collection system are showing the highest INI impact. So you'll see on this graph a list of locations, some rain sites, a chart, and I'll skip that for a sec, we'll come back to that. And then you'll see an INI impact percentage. And again, that's that dry weather versus wet weather period comparative study. And then the last thing, this software also tells them the delay. So it tells them how long it took for that rain to impact the collection levels at that location. And then from there, what you can do is drill down. This is from a totally different site. But you can see some pretty significant spikes in water levels. If you ignore the graph on the right, just look at the one on the left. Some pretty significant spikes in water level. And now, without remote monitoring, first off, these types of level increases may be happening in your system, and you have no idea they're even happening. But when we overlay the rain data, so that's the red you see on the graph right now, it becomes very apparent this is rain-driven. All the level spikes on this chart happen at the same time during rain events. Above here, you can see two sites, also from BC, with really dramatically different INI correlations. The site on the left experienced a rain event, a pretty significant rain event denoted in red, and the corresponding levels at that location barely increased. I'm not sure if you can see at home, but the level, or the INI impact, detected there was a mere 3%. So essentially a non-existent INI impact for this location. We compare that, though, to the site on the right, which had a couple of rain events of similar proportion that resulted in some dramatic spikes in levels, high enough to actually trigger high-level alarms for this customer. These particular rises were still well below grade. These are deep manholes, but a significant problem when your collection system levels are coming up out of the invert, over the bench, into your manholes. And without remote monitoring, these types of events could actually be happening in your system without you even being aware, until maybe, unfortunately, it's too late, and you get such a big surcharge that you now have an SSO event on your hands and a big cleanup. Now, across a municipality or a regional district, some regions are going to be more impacted by INI than others. And that can be caused by many factors. That could be age of infrastructure, could be the amount of storm connections that are improperly tied into the sanitary, among other things. And I've just thought I'd throw a couple examples from a few cities. The one on the left is from the city of Burnaby. The one on the right is again from the city of Fort St. John. Both of them, the amber or yellow line is rain data, and the blue and red lines are two different collection level locations being monitored. In both examples, one section, which is on a different part of the municipality than the other, showed a much higher correlation to the rain event. So typically, when you're starting an INI program, you want to begin close to your treatment plant and work your way upstream, further up the collection system from there. For those collection systems where your wastewater goes to a regional system for treatment, then beginning close to that handoff point is where you're typically going to start and work your way upstream from there. So this hypothetical system here, they decided they would start with 7 remote monitoring sensors and left them in, monitored periods of dry weather compared to periods of wet weather, and let the software tell them which pipe segments or which regions or zones in the city were showing a higher INI impact than the other. And then the next step is to just simply reposition those sensors where less INI was detected further up into the collection system. So you're kind of leapfrogging, if you will, like it shows in the chart. Those sensors have now moved further up the collection system, trying to track down where those highest INI impact locations are in your city. You can see here quickly why having a technology that's non-contact and, more importantly, non-confined space entry to install and service becomes really advantageous here, because you can quickly re-and-read these sensors in new locations with ease. This will then, once you get into a more focused section of your municipality, maybe coupled with smoke testing or CCTV camera inspection or whatever preferred method you like to use, but now you're doing this in a much more focused section of your city rather than broadly across the entire system. One last one here on I&I wanted to show you, and this is a pretty significant one. So on the graph here, you can see two pretty significant spikes in level during rain events in Lake Country, British Columbia. With this data, they were actually able to track down a very large, illegally tied in, or maybe incorrectly is a better word, I'm not sure if it was legal, storm connection from a commercial operation. And that was causing these significant inflow events. This connection has since been rectified, and these inflow events are no longer occurring. So if you take a look at the graph here, you'll notice, again, red is our rain data, blue is the water levels at this location. And this sensor had only been installed in a few days. We got the sensor installed, I think, on a Wednesday, and that first rain event was on a Friday. And you can see, when that first rain event came, a significant spike in levels. A few more days of dry weather period back to that standard diurnal pattern you'd expect. Another rain event caused, again, the same idea, a significant rise in levels at this location. So armed with this, they did some investigative work, and I don't know the backstory on how they figured out or found this commercial storm connection tied in, but they rectified it, and then about a week later, we had another rain event, which was very comparable to the second rain event in volume of rain. You can see that on the graph, but absolutely no increase in levels. So like we talked about in the previous slide, the district could now look at repositioning these sensors further up into the collection system to continue tracking down significant sources of I&I like this. There we go. So throughout this presentation, we've focused on just a few applications where smart monitoring technology can assist your operations. However, we work with municipalities across the province using the same types of technology for really a plethora of different applications. Some will use smart monitoring technology to monitor surface water, like rivers and streams, leachate ponds, reservoirs, things like that. Combined sewers, so if you want to get a sense on how much volume during an overflow occurred, and also what amount of rain triggered your overflows. Maybe temporary applications, so if you're doing work on a lift station, you may want to install a remote monitoring sensor to give you a remote window into what's happening there in case you have issues with your generator or that bypass pump. And I could also point you back to the city of Kelowna for a perfect example of this, where they put a remote monitoring sensor on a bypass pump. The generator failed and would have caused a sewage overflow in an industrial park had they not had this remote monitoring technology. And then on that for lift stations, because remote monitoring technology does not require any power, it's an off-the-grid redundant backup. So maybe on things like a critical lift station, this gives you that peace of mind to know what's happening at the lift station, that if power was knocked out or anything happened, you have this independent, redundant, off-the-grid backup to let you know what's happening. So the city of Kamloops is a good example of this. They have a lift station down by the Thompson River that would be catastrophic should they have a problem with that lift station. So they have a remote sensor on the last manhole before that lift station to profile it, but also to babysit and make sure everything's working as should there. One municipality, and I have touched on them a bit today already, but I'll go back to them, that's been very proactive in the use of remote monitoring technology, not just with H2S, as we previously talked about, but across a myriad of applications, is the city of Kelowna. So I'm going to single them out again. They have remote monitoring sensors now on their wastewater system, monitoring also H2S levels as well, stormwater, their surface water system, and even on the potable water side, monitoring pressure at a PRV station in the recently acquired Southeast Kelowna region of the city, where it was going to be too expensive to run telemetry and power out to, so simply installed a remote monitoring sensor using the exact same technology they are for everything else and on the same cloud-based network. So if anyone's interested in that case study, again, just reach out to me like I mentioned about the video before, and I would be happy to send that along to you. What I wanted to now quickly talk on, because it's starting to get a little short on time here, is some things to consider. So if you've never had any remote monitoring technology, what are maybe some things you want to consider? So the first one is, what are you trying to do? So what's your objectives? Are you trying to reduce maybe a high-frequency cleaning location? Are you trying to babysit pipes and prevent sanitary sewer overflows? Is it an I&I study? Any of these, what you're looking for and what's more important than anything is information on the water levels going through. Although most non-contact sensors can provide flow data, in addition to level data with some parameters maybe like pipe slope, but level is really what you're looking for in those applications. If you're trying to do a flow study where you need down to the liter accuracy of flows, then at that point maybe you're looking at an area velocity meter, something that goes in the flow, very accurate, but comes at a much more, much greater expense to both install, maintain, and service. Durability. So it's key to have something that's IP68 rated. So a sewer, as you can well imagine, a pretty harsh environment. So something that can hold up to the rigors of being in there. Battery life, this is an important one. So because remote monitoring sensors are off the grid, not requiring power, makes them very portable, easy to install anywhere in the system. But what's the battery life? Is it 1 year? Is it 2 years that the battery's warranted for? Is it longer? And what's the sampling frequency that's based on? Is that 5 minutes? Is it 15 minutes? Those are important questions. So there's this constant dance between sampling frequency and battery life, and one is at the expense of the other. Portability. So are you going to move these units around? And we talked about this with the I&I component. If so, you want to be able to have something you don't have to get in there with a tripod and a confined space entry to install and relocate every single time. So having that non-contact, non-confined space entry sensor becomes very advantageous. And I think back to just before Christmas of 2019, so last year, pre-COVID, when I was down here working with the city of Burnaby, and we were relocating a few sensors further up in their collection system, doing some I&I studies. And these sensors are right by Metrotown, 2 weeks before Christmas, so extremely busy time, as you can well imagine. So having these non-contact sensors made for an extremely quick re-and-re. So we had to have traffic control and all of that set up, and yet we were able to relocate these 2 sensors out of one spot, including drive time, traffic setup, and have them back in different manholes in under an hour. So that's an important thing. If you had to have a tripod set up, you can imagine how much longer you're impacting traffic. Next one, how does it communicate back to the cloud-based network, and how reliable are those communications from one of the lowest points in your infrastructure, i.e. a manhole? Some systems will use cellular, while some will offer different things, including one that we like to use, which offers satellite. So it gives it versatility to work in any location, whether it's urban, rural, doesn't matter. The location is irrelevant. So that's something to consider. Is it a two-way system? So can you make changes to things like the sampling frequency or the alarm height? So say you want to change what level in the invert you are triggered with a high-level alarm. Can you make those changes remotely, or do you physically have to drive out to make these kind of changes? Visibility. So if a sanitary or a storm line is starting to back up, having a sensor that gives you visibility from the bottom of the invert right up to the manhole lid can really provide you some critical information during those times that can help not only mitigate damage, but also assist in future planning. Ease of use. So is the system easy to use? And that's an important one. It shouldn't require a 100-page novel or 15 engineers to figure out how to use the system. It should be easy to deploy and navigate the data. And then one last one I always like to reference is references. So if you're looking at getting some sensors installed, first thing I'll tell someone after we go through a presentation and they're interested is put them in touch with other municipalities that are utilizing it for the exact same applications. There's really no better reference for you guys than to speak to your peers. Okay, and I do want to leave the last few minutes here because we've got under 5 minutes left for questions if there is any out there. So for those attending from other municipalities that would be interested in having cloud-based access to one of our vendors' portals, what they've agreed to do, and we have some cities that are graciously willing to share their data in a sandbox environment, if you will. So don't worry, you can't break anything. You're not going to set off any alarms. But it would give you kind of a window into how they're using the technology, how these cloud-based portals work. If you're interested in that, I'd be happy to set you up with a temporary access so you can see that. You can navigate it on your own, or if you want, I can kind of work your way through it and kind of explain what they're doing with the technology and how it's assisting them. And then you can certainly ask me any questions on how it may apply to applications you have. And that's basically it for my presentation. So I did want to turn it back over to the moderator and see if there's any questions out there from the audience. Normally I'd be looking at you, audience, but you're not here. So, okay, so I see a question that's come in here. And the question is, what is the cost to implement these remote monitoring systems? So good question. Remote monitoring, like a non-contact sensor, you're probably looking at, to give you a ballpark, about $6,000, $6,000 to get a sensor. And then you're going to have an annual subscription to that cloud-based system, which is covering the portal, but also your communications. And I would ballpark, or to budget, maybe you're talking about $1,000 a year for that. That, again, is going to depend on the sensor provider. But that's kind of a ballpark to give you an idea. Looks like that's the only question. So I think if there's no other questions, I will turn it back over to the EOCP.
Thanks so much, Matt. Just got that one there for you as well.
Great.
Yeah,
Thank
awesome.
you.
Thank you very much.
Thank you.
Cheers. All right, guys. So yeah, just to wrap up, thanks Matt for that one as well. Thanks for all the presenters for coming out for the conference, and thanks so much for you guys at home for watching as well. Just want to thank all the sponsors, all the presenters that we've had in here, and just to you guys as well. Remember to do the survey. Let us know what your favourite presentations were, and hopefully we'll see you all here next year in person.
Thanks for attending.
Awesome. Thanks everyone.
Take care.
Bye.